Okay, hello everyone. We are going to do a task. This is your homework. It's a very good activity. Too bad I don't have time to do it in class, but I want you to do it because there's something after this activity that could be very beneficial for you during the AP exam. Now, imagine today's activity is that you were given kind of like 5 little pieces of the puzzle, of a big puzzle, right? You have, maybe there's like 1,000 pieces, or you don't know, but you were only given 5 of them. And you have to use this 5 to use logic and math and sampling distribution to find out what the entire picture looks like. It's really cool, super cool activity. All right, so now, how does it work? This will be given to you. So now, during one of the battles over the Pacific during World War II between Japan and America, the Americans shut down 9 of the Japanese planes. So each one of them had a number. Let's assume that it is a serial number, like a serial number of a plane. And then they recorded. And then the general obviously could deduce that there are at least, remember this is a serial number, right? So they produce one, and they produce a second one, and then eventually they make 255 of them. Can deduce that there are at least 255 of these warplanes. So the general wants to find out how many total planes there would be in this war that he will still encounter. He only shut down 9 of them. So now he gave you this information, and he wants you to figure out, or at least to the best of your ability, to find out how many total planes there are still in the Japanese armory that he will encounter later, so that he could use his force appropriately. As you can see, it's totally relevant, and then it's very pressing that you figure it out how to do that. And that's what you're going to do. So you are now at home in Pentagon, and then in the war room, you have to figure this out, just giving this. What do you do? Let me give you a graphic representation of today's scenario. You have a population of n, size n. You don't know what this number is, but you somehow were able to randomly get 9 of these warplanes numbers, serial numbers. You shot them down, and then the soldiers recorded it. So obviously, it's very beneficial for you to know this, because during the war, the general can ask for more reinforcements to take out the rest of the planes, or at least if he realizes there's not that many planes left, then he could ask the other generals to attack from a different angle, to allocate resources appropriately. So it's your goal to take this and predict the best possible total number of warplanes. Okay, so your homework is to do, it says 3, just do 2 mathematical models, and then pick one that works better than the other. Well, you're like, whoa, I don't know what to do. That's all right. I'm going to set you up for success. Okay, so here is a strategist in the war room that could help you. So he proposes that, since we don't know the total number, so why don't we just make up a total number? And then we're going to be given 9 random numbers from the total number. And then we try to create a mathematical equation or a model that allows us to predict the number in this particular scenario, this just random simulator. Turns out to be there are a total of 386. Well, obviously this time you know how many total numbers there are, but in the real scenario, you don't know, right? You're only given 9 numbers. These are random numbers. So if you, if you just type in a random number and then this thing would just switch by itself. It just pick randomly 9 different numbers. So now, why don't you predict that you don't know this number, 386 on the left, and then you were only given 9 random numbers. So if you can somehow use this 9 random numbers to come up with 386, then that means that your simulation was a success, or at least very close to 386. Then that mathematical model can be applied to the Japanese warplanes. And then let me tell you right now, statistics, super cool activity. Because a lot of the times in life, most of the time in life, you're only given limited amount of information. And then if you're smart enough to create a math equation or a math model to extrapolate, and then to extrapolate from this small amount of information and get lots of at least generalize this information to other things, then you are likely to make more money. Like you are likely to be more successful because you could see the big picture given very little amount of information. All right, now, why does this model not work? So what do I propose in this first model? Let's just say there's a person in the war room. He proposes that, why don't we just find the max number? So right now, the max number for this is 362. And then I do it randomly another one again, 311. And I do that again. And then I just say 379. Okay, let's just say that I do that a billion times. We don't have time for a billion times, obviously. Let's just say that you do it for 50 times. Okay, and I take these 50 times and I plot it in a dot plot. It will look like this. Because obviously this is the max number, right? So you're like, yeah, of course. Then, all right, then maybe the sampling distribution of the sample max works for our thing. But no, it doesn't. Because obviously over here, you are given the luxury of doing this over and over again. But today, you don't have the luxury to do it over and over again. You are only given one dot. You are only given 9 planes. There's no more data. So just think about this. There are so many of these dots. There's a couple of them that's true. Obviously, you want to know the true number of warplanes so that you could react accordingly. But most of these numbers, it could be, there's 9 data points that you were given over here. Could be here, or could be here, could be here, could be here, could be here, could be here. Of course, it could be true that 386. But you're way more likely to get it lower than the true number. You are likely to underestimate the number of Japanese warplanes. So in a war, that could be very costly. So I explain it also over here. It's your goal to come up with 2 models, one good and one better. Your homework is to bring 2 of these pictures to class next time. Okay, good luck. It's so fun. It's a really cool activity. Figure it out. You could do anything. You don't have to do sample max. You could do range times 5. You could do min plus 100. I don't know. It's your goal to predict, try to get to 386 as closely as possible.